So I think that's something that we can definitely look forward to in the near future. We tend to take a lot of oil samples that would even before an engine may have failed, because that's always a good telltale sign of an engine about to fail.
Yeah, I'm back, man. You know, George,
Yeah.
unreliable internet connection, moving like George Russell in Australia.
In reality, they're the unknown unknowns. So they're things that you haven't considered. There's scenarios you haven't considered that can then contribute to your engine failing or in various different ways. There's not really been many, I guess, big game changers so far. Really, all you need to do is make sure is that you're able to achieve really, 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 really high. Well, it says that high combustion pressures and
Hello and welcome to another amazing episode of the Stripping the Dipping podcast. You're joined by your usual co-host, the MDM, the modern day Morgan Freeman. And what can I say? You know, we love to bring new people onto the show. We love to have returning guests to the show. And I've got a really popular guest amongst our technical listeners, which gave us some amazing insight into the world of F1 last year. And, you know, it was an absolute banger of an episode, if I do say so myself. Hold up. And, you know, bringing that energy, I'm really happy to say that I've got my bro from actually the same secondary school as well, which is a madness. I'm very happy to announce that we've got George Brown, engine designer from a very, very reputable team that makes energy drinks. So I'll let you guess that. But George, man, how's life been since we last caught up, man? It's been sensational.
Awesome intro again. Thanks for having me on again, guys. Love the intro again, man. Life's been good, busy, but yeah, all good.
Oh, bro, that's excellent to hear, man. Bro, we need to have a proper catch up on that. And, definitely, there'll be obviously listeners that will listen to this and be like, oh, yeah, I remember George and the amazing insight you gave us. And also, as well, obviously, some new listeners, which we also love as well, that, will love to learn more about what you do, kind of like how you got to that stage, and kind of like almost an evolution, if I do say so myself, from the previous episode we recorded with you in season 1. So, George, I'll hand the floor to you. Can you tell our listeners, especially for the newer ones out there, what you do, what your role is, how you earned that opportunity, and yeah, just like what day-to-day life looks like as a design engineer?
Yeah. So I'm a design engineer at Redbull Powertrains, or I guess now we're Redbull Ford Powertrains with that Ford link up. I work at the moment in the mechanical development department. So I don't necessarily design PU components. I work more within the sort of put together rigs that sort of sign off, develop different PU components. So I do spend a lot of my time putting together different sort of, I guess, test systems of varying different sizes and scopes for different parts of the PU. I say PU because I basically work on not just rigs for the actual engine, but more on the ERS side as well. So pretty much day to day, pretty much I am doing a bit of design, trying to get rigs together, sort of liaising with component designers on requirements that they would like to get out of sort of rigs. Putting rigs together through a design stage, holding reviews, and then sort of liaising with project managers, support kind of departments, getting bits together and to be built up, working with the facilities guys, because those test rigs would need different systems to allow them to work, so whether it's three-phase electricity or water connections or compressed air. So I'm pretty much kind of like a middleman between PU designers who are basically designing certain components and kind of the test team as well. So guys are running the tests. So in a way, kind of pulling the strings for different subsystems.
That is really awesome, George. And again, as well, with your role, it's so like all encompassing. And you mentioned there as well, like putting together these huge rigs, especially as well for the ERS, the energy recovery system, which has become so complex, in the modern day kind of evolution of cars and especially power units and the way that the ICEs work with the hybrid systems as well. And also as well, could
Mm.
you kind of give us insight as well into kind of like what it's like to deal with like component designers and kind of like the kind of, I guess, phases of liaising with them on different design concepts, or kind of running through kind of like how you analyze data or stuff like that as well. Like, how complicated is it? And is it something that you always knew that you wanted to get into from obviously the good old secondary school days, or is it something where over time you've seen this kind of space kind of within the Formula One world, and something that you've aspired to and worked for more, for our listeners tuning in for the first time?
Yeah, sure. No, I always knew I wanted to get into engine design. It was a sort of passion of mine from a young age, really. I could have sort of gone the chassis route, worked through being a vehicle dynamicist or even an aerodynamicist, but I think I was quite passionate about the engine, the power plant, and really kind of the different subsystems and interconnecting parts within it that always fascinated me, kind of putting that together. And different ways and combinations that you can put together to try and extract more power, because at the end of the day, that's kind of the ultimate goal of putting together a Formula One power plant or a PU. So I guess just to kind of put it in a nutshell, really, yeah, I always knew I wanted to work on engines, and that was it. So I was basically going to go into kind of the many different roles that you can actually get kind of working in Formula One. So obviously you can get to be a designer or an engineer, but yeah, even as being an engineer, you can either work in analysis, you can work as a designer, you could work as a supplier quality assurance engineer as well. So they basically are responsible for making sure parts that we get made externally, they come in correctly with sort of the right treatments, post treatments or manufacturing processes, just so that we're able to get the functions that we've actually designed into the different parts. That's a very, very important role as well, because obviously working in Formula One is a very high pressure environment. You're working very fast pace. So you're making, you want to get stuff done very quickly, but you want to do it correctly as well. So that's a very important role as well. And it's obviously various different roles as well. Obviously, project management is very important in that. Making sure that things are being delivered on time, and there's good communication between different departments as well. So yeah, just to put it plainly, yeah, I kind of always knew I wanted to work within the design side of an engine. So, but kind of in the beginning of my career, I've always kind of flirted on the lines between design and development. So I guess that's kind of how I found myself into this role that I'm currently in.
Oh, that's amazing to hear, George. And again, as well, like, it's not by fluke. I would say it's by design, because you've put the work in, you've always had the vision, and you've pursued that kind of line of thought, and just, you followed the trajectory of how an engineer would come through the ranks, into like an award-winning team that you're in at the moment. And like you said as well, it's so high pressured, and having the responsibilities, having just the kind of thrive and determination, enthusiasm, the communicative skills as well, to be able to liaise with people and really come together and synthesize a result which results in performance on the track, I think is probably one of the most rewarding things to come out of what you do as well. So it should be a huge inspiration to our younger audience, and of course as well just to anybody, to pursue your dreams and aspirations as well. So that's an interesting one, Judge. And before we turn on to the other subjects, again, I don't want to land you in trouble, so I'm going to keep it very generic. But we know that there's Redbull going into a new kind of era. We know obviously that they've got their own kind of like division with the Redbull powertrains. Obviously, as well, at the beginning of the season, we then learned that Ford were going to be part of that journey for you as well. You may recall, like in the previous episode, we are talking about like working cultures and practices, and kind of the experiences with working with Honda, and how they have their own unique philosophy when it comes to manufacturing engines, designing them, and like integrating the unit itself in with the team. But how exciting is it for you to work with like a heritage brand such as Ford, which have achieved so many feats in the world of motor racing and have their own kind of different style? And how do the two contrast and compare? And how excited are you for the future, of Rebel powertrains and the kind of future projects that they have lined up, not only in F1 but probably outside of the sport too?
Yeah, no, it's really interesting, to be very honest. I think what it's really still to be seen, kind of how, as you kind of mentioned, the culture, how it kind of all comes together, because obviously Rebel Powertrains, obviously being a new company, it's going to always be an amalgamation of different, because we're hiring, got people from, pretty much all corners of the world. So there's like an intermixing of kind of different people who worked in different places, and obviously culture comes with that as well. So it's at the moment it's very interesting to see us kind of growing and to kind of become our own entity in that way. But yeah, having Ford on board is definitely very exciting. But yeah, I think, to be honest, it's still quite early to say. There's so many options out there, and things that I think we could be getting involved with Ford. But yeah, we'll have to wait and see.
Absolutely, but again, it's really exciting to hear that, George, and to know that we'll see Red Bull kind of reach out, branch their wings. No pun intended there, with the Red Bull gives you wings kind of motto or strapline there. But we live in a kind of day and age as well where we'll talk on it a bit later. But you've got the prototype series with the World Endurance Championship by the FIA, or the whole kind of GTP class with the IMSA kind of series, and all these manufacturers such as Acura, Porsche, Cadillac, Ferrari, just even Peugeot kind of coming together with these hybridized, power unit systems that are heavily complicated, but again, taking some of the world's leading technology and implementing it into, efficient, cost effective, and great kind of like sustained racing formulas. So to see Red Bull kind of launch into that as well is amazing. We already know that Red Bull have a kind of history of taking part in different projects. We had Adrian Newey on the more aerodynamical side, dealing with I believe it was Aston Martin in the Valkyrie project, and having his hand in that as well. So it'd be interesting to see it go the other way, having kind of like the Red Bull powertrain guys like yourself kind of working with manufacturer in the future like Ford, and seeing how like the harmony of both like a manufacturer but then also kind of an engine developer and designer like yourselves come into that as well. So really,
Yeah,
really exciting. But
no,
also let's
absolutely, yeah.
for sure. And another thing as well, on the topic, of like the future and engine rigs as well, George, one of the fan questions we got in today as well is, what is the 2026 engine rig change? How big are they? And like, how far ahead of time the teams generally start developing and prepping towards this? Because I think maybe one example that our fans would think about was Mercedes, during the turbo hybrid era in 2014, and maybe some of the
Yeah.
works and infrastructure that was put in place before that to enable the team to gain such a dominant kind of like advantage. Could you give our listeners kind of like an insight into what the changes are, what the aims of the changes are, and
Mm.
generally kind of what kind of things go are consideration, for like a works team?
Yeah, I'll give it my best shot, to be very honest. In a funny way, this is going to sound crazy. Like, I don't know exactly myself all the changes, because they're still a little bit work in progress, if that makes sense. So I
Okay.
think there's still some back and forth with all the teams, and obviously the FIA trying to get an agreement in place. To be very honest with you, I've not really been keeping massively up to date. Because there've been many different revisions and changes. Um, I mean, I don't know how much I can actually speak on certain things. Basically, there were certain bits that were coming in. In the early days, it seemed like a bit of an overhaul, and I think over time it's kind of been reverted. It's a lot of stuff is being kind of taken away, because I think you have to understand there's the motivation of the FIA to make the engine development more competitive, kind of to balance it out a little bit, so that, I guess, obviously what you had in 2014 is you had essentially technology that was being borrowed from different divisions from car engine manufacturers. I'll kind of leave it there, to be honest. But yeah, so effectively, NGH was a derivative of something that was being used in diesel engines, for instance, and it's obviously allowed Mercedes to be very dominant over those coming years. So I think number one, things like that were things that the FIA were probably trying to avoid happening going forward. But at the same time, a lot of teams didn't want to lose their current competitiveness, especially teams that are already kind of established in terms of things that they're doing. They didn't want to sort of do too much work for 26. So there was a lot of negotiations going back and forth, and I think that the rules kind of were swaying one way one minute and going the next the opposite way the other minute. So it's still a little bit up in the air. Obviously, you've got newer teams like as you said, the energy drinks manufacturer, as well as the new German car manufacturer as well that have entered the fold, and possibly, you know what? Let me just stop talking. I don't really want to get into the rumor mill, but yeah, in terms of the amount of teams that are going to be that are working on 26, it's not defined, but basically they're still work in progress, because I think you've got different teams with different motivations, and I think there's still some negotiations to what the regulations are going to be.
Absolutely. And you know what, as well, Judge, that was a fair answer too, because, you know, with stuff like that, and we know how the FIA as well, trust me, we cook them regularly on this podcast, but some things they don't always get right. You know, it's a moving thing. It's not going to be a static thing where rules are already in place or agreed between the teams 3 years, I guess, in advance. There's still a lot that needs to be discussed, like you mentioned. And also, it's interesting you mentioned, even just from the commercial side of it, the teams have different interests for why they want to come into Formula One and have a crack at these regulations. The FIA also have their motivations, and we've seen how they're more willing to work with certain entities that, you know, are actually car manufacturers, and then maybe some other individuals where they don't bring a manufacturing kind of background, more just a sporting legacy. Sometimes how they'll be challenged or put through different kind of tests, trials, and tribulations to see whether they merit a place, you know, in Formula One. So it's interesting, you know, and I think, like you mentioned as well, we've seen another kind of like team, again, to kind of take your kind of line of phrasing as well, like a German manufacturer. I think they got 4 rings on the front. Who knows? I only deal with the one with the 3-pointed star though, but only drive that one, bro. but yeah, just like, it's interesting how even that team, for example, that we're alluding to, like, you know, they've decided to not really interrupt too much of what's going on at Alfa Romeo Sauber at the moment, because they're probably doing their own things in the background to make sure that they get a deal or they get certain provisions with the regulations that benefit, you know, the way they're going to go about it. And, you know, interesting as well with that manufacturer, they've already kind of said that, you know, the GT3 program that they're running might not be as supported because they're going to put more kind of emphasis onto F1. So it is interesting to see how the landscape of motor racing changes and the motivations for these companies as well. But it's a generic question as well, there, George. And I think what I'll do from here on out is I'll be a bit more tame in my phrasing of some of these questions. But, you know, also just, you know, for the fans out there about F1 that are quite skeptical about emissions and kind of like, you know, making racing sustainable, you know, and like we mentioned as well, kind of giving the floor to a wider plethora of manufacturers coming as well. Do you think that from what we've seen so far with the aims of the FIA, that's going to be achieved, that we're going to get more sustainable racing, you know, more kind of carbon neutral kind of like solutions to a lot we see as well with the new technology? Is that something that could be looked forward to as well for, you know, our very eco-friendly warrior friends out there?
Yeah, I think one of the changes there's going to be definite for 26 is obviously the change in the carbon neutral sustainable fuels that they want to be using, which I think obviously is going to be the same for, I think, pretty much all the engine manufacturers. So I think that's one way the FIA or the FOM or Formula One themselves are looking to make racing more sustainable. So I think that's something that we can definitely look forward to in the near future. As for alternative technologies for more eco-friendly power plant propulsion, again, based on my previous answer, you get into kind of the positions that different teams, obviously teams would have to agree to obviously kind of back that as a regulation. And again, you then start to see obviously different engine manufacturers will be in different positions with that. Obviously, you may have some car manufacturers who are already all into that, even ones that aren't even in the mix at the moment. They may prop up and go, hang on a second, we do a little bit of that. Let's put our hands in there. And obviously, you may have other ones who are like, yeah, we're at ground zero. That not interested. Sorry, we'll be all the way back. So I think that would be the hurdle that we would need to get past in order to see kind of alternative technologies even being considered, sort of coming into Formula One.
Absolutely, but I think it's good that at least we're having this conversation, but also obviously higher up they'll be having these discussions as well. And the kind of CEO of the sport as well, Stefano Domenicali, has made it quite clear kind of what his intentions are and the direction he wants to go from. And again, it's interesting, to see an individual like that's worked their way from Ferrari, then had some time away working with Lamborghini and the Volkswagen Audi group, and now kind of back in F1 because they've got that relationship. And while sometimes I think some things get missed in translation with the fans and maybe the way decisions get made, from at least a manufacturing point of view, a guy like Stefano Domenicali kind of knows, the kind of processes and the considerations that these huge conglomerates take into consideration as and when they commit themselves to such a huge, cause such as Formula One in terms of its competition and stuff like that as well. So it's interesting to know that the discussions are still going on. Of course, as well, there's still a fair amount of time. So, I guess as time goes by, we'll expect to see more and more. But it's good to know that, it's not kind of fallen on the back burner. And actually, if we already have Audi confirmed, if we already have, certain other entities confirmed, like you mentioned.
I will put a disclaimer. I'll put a disclaimer out there. To be honest, I haven't caught the latest episode of the sporting regulations, the technical regulations saga. But from last I've checked, I think that there was a lot of back and forth. Whether we fully confirmed, I'm not entirely sure. But I know that, a lot of different teams obviously had different requirements that they liked, which kind of prolonged it or there was some alterations to it. But that's kind of where I'll put it. So it may have been agreed already, but I actually haven't been up to date with all that.
Well, knowing the luck of this podcast, George, it'll only take us to release this episode, and then we'll just see a huge article from Autosport or F1 management themselves. So, definitely one we'll be keeping our eyes peeled for. But anyway, we'll go on to the next question then, which came in from a fan too, George. On the topic of Georges, we obviously had George Russell, which, was leading the Australian Grand Prix. Man was living his best life. Man had the Gucci sliders on, had his teammate Lewis just in a stable second, had Max harrying them with a nice DRS in third place. Unfortunately, Alex Albon has a bit of a mare and so forth that causes a safety car. Only after the safety car, then a red flag gets called out as well because it's just too much debris on the track, bro. It's looking real messy. I don't mean the Argentinian either, So they red flag the race, restart it, and George Russell, probably from like P6, is fighting his way up. And then, bro, boom, absolute disastrous monstrosity. Engine has a cataclysmic, new word for me there, failure. As, the car just went in absolute fireballs. And what we've been told through sources is that Mercedes may put it down to debris getting inside the engine and causing it to malfunction catastrophically. The question was, George, for you, kind of generically and just generally speaking as well, what does an autopsy process look like for a failed engine, in the case of someone like George Russell, where you've just had a power unit just go bang, and how easy is it, for debris to get into these very compact modern day packagings that we see with all of these cars? And just like what actually happens to the power unit at the end of its cycle? Does it get recycled? Does it get destroyed? Can it sometimes be repurposed for other things as well, like testing? What is the line of thought that happens when something huge like that goes wrong?
Yeah, that's a fantastic question. Well, all engine manufacturers, even outside of F1, they tend to have a strip team. So there tends to be a strip area where essentially, you perfectly put it, an engine basically goes through its autopsy. So in the event of a failure or some sort of how to put it, if the engine's not sort of behaving the way it's meant to, or it's had a catastrophic failure, it essentially gets stripped, as we call it. So the engine essentially gets taken apart. Usually, you'd have a massive failure, so you're kind of obviously taking apart bits to see what the root cause of the failure was. And there's several different techniques that you'd use to kind of try to gauge from the parts that you have in hand, failed or not failed, or ones that are kind of were basically collateral damage. So you have a lot of material scientists within the teams as well. So we'd go through several tests. For instance, we'd basically put parts through a CT scanner, where I guess to put it plain or layman's terms, you're basically you're putting the parts through an X-ray basically. So you're looking to see kind of any defects that may have caused a failure or results of failures, and that may give you a clue for how the part may have failed. You tend to do a material analysis as well, not just of the metallic components, but also of the fluids within the engine. So, for instance, we tend to take a lot of oil samples that would, even before an engine may have failed, because that's always a good telltale sign of an engine about to fail. So a good example is if you're experiencing a lot of wear within an engine, you can take oil samples before running, which is obviously, I guess, what you call clean oil. And then sort of during running, you may start to get bits of metallic components within it. Depending on the metal that shouldn't be in the oil, that can give you also an idea of where the failure is coming from. So if you're getting lots of wear from, I don't know, a pump or somewhere within the crank train, for instance, because obviously oil kind of flows through all these areas, lubricates them to minimize wear, to obviously act as a secondary form of cooling. You tend to get kind of a picture when you start to see, bits of aluminium or bits of whatever, magnesium, for instance, is showing up here. That's a bit weird. The more rare the metal is as well, the more you get to, that's coming from X, that's coming from Y. So that can start to give you a kind of a picture of kind of where failure is about to happen. And obviously, going back to strip, you would still run those kind of oil samples through the oil, obviously, that you've drained during the strip. That can also give you an idea of kind of what's been happening prior to it kind of just catastrophically failing, for instance. As I mentioned, you put the components through material analysis as well. You can kind of ascertain whether there's been a bit of fatigue going on within certain highly stressed components. Usually with that, you're looking kind of under microscope for kind of striations. We call them striations. They're basically like waves that you'd get. So if you were to, how can I put it? So depending on how the component would fail, let's say, just say a conrod, for instance, just hypothetically speaking, a conrod kind of, you break it into how those surfaces that weren't previously kind of, so where basically the split line, where it failed, the surface, how it looks, that can always give you a pretty good picture of how that failed. If it was due to fatigue, you tend to get what you call, I just mentioned, the striations. They tend to be like waves, and that's basically telling you that part didn't just fail initially, it was being highly stressed over a certain amount of time, and that was basically creating these waves, because it was obviously it was cyclical, because a lot of fatigue failures is cyclical. It's over a matter of time, and it can be down to loading that's not even meant to cause this to fail in the first place, but it happens bit by bit over time. So you tend to get things like that as well. So yeah, these are the things that you basically be going through. So over at up the road, they probably would have stripped the engine, kind of, I guess, come to the conclusion that some debris must have come in and caused the failure. Can be possible. Well, I reserve judgment on it. I'm not going to. Yeah, it could be possible. To be honest, anything's possible. Um, so I can't really speak too much on how often that happens. Anything can happen at any time. But usually, yeah, you can get the way they would have ascertained that was the issue. Something else would have happened, but it may have been caused by the introduction of debris into the power unit. But yeah.
Wow, that's really interesting to hear, Judge. And again, like this is the forensic approach that the teams take towards diagnosing the issue. You mentioned there as well, like the material analysis and almost in the sense of how the team have like, like a science kind of composite team as well that pick up on these things and almost kind of like rewire the failure backwards, kind of trace the
Yeah,
roots and some of the
yeah.
things, whether it's fatigue, load,
So
just something.
another thing to add. Actually, I should have added. This is quite important. A lot of the components, actually, no, all the components in the PU, they get heavily tracked in terms of their mileage, because that gets fed into the kind of fault analysis as well. So, in fact, all over the whole car, actually, you tend to get, if parts have been used for a certain long amount of time, that can give you a telltale sign that actually this part was designed to only be used within this certain amount of mileage. It may have been reaching its end of its mileage, and that may have caused or contributed to the cause of failure. So that tends to get contributed or factored in as well. So I just felt I had to add that as well because that's a kind of a very important factor to
Oh,
yeah
absolutely,
tracking an
absolutely,
engine.
Judge. For sure, and we, it's interesting we hear that too, because even in other kind of like engineering kind of like backgrounds or industries, well, even like in like the aviation world, you hear about kind of like Boeing 747 engines being made to last X amount of mileage before certain parts need to be updated or upgraded or
Yeah,
changed, and like a certain kind of amount of stress or fatigue it can take before it gets to the point where the reliability of it or chances of something going wrong increase more statistically.
yeah,
So it's really interesting to kind of see how that also translates into the world of F1 too. And a follow-up question actually came from a fan on this one as well, George, was like, so kind of the hypothetical scenario we mentioned, we've had like a engine have a cataclysmic or catastrophic kind of like failure. The question was, George, is like, how much does this affect the dynamics of the team if, let's say, for example, a similar failure happens again and the team haven't been able to diagnose or, in a sense, find the root cause of the issue? Does it become a bit more tense, the kind of working atmosphere to try and get it done or figured out? Does kind of like the conversations start having being had with people higher up in the chains as well to kind of clamp down on it and to try and find it, and is it the case sometimes that with these things it might be just like like you mentioned, this kind of running through kind of like a kind of like, for what we'll say is like a clinical autopsy of the parts, or sometimes can it take months to actually find out fundamentally what is wrong with the issue in terms of reliability and to implement something in there that will strengthen or reduce the chances of it failing again.
yeah. No, absolutely. That's another great question, to be honest. I'll answer it in an ideal world first, and then come back into reality. In an ideal world, obviously these are failures you try to preempt with a lot of testing, a lot of reliability testing, durability, subcomponent testing, which where rigs come into. And the hope is you kind of done all your testing, you put everything together, and you have a super duper powerful engine, super duper reliable, never breaks down. Everything's great in the world, and you kind of go ahead. Obviously, in reality, they're the unknown unknowns, so they're things that you haven't considered. There's scenarios you haven't considered that can then contribute to your engine failing or in various different ways. And what you tend to happen is obviously you would, yeah, it really depends on the team. I guess the right way of doing it is you have a kind of, I guess, a sophisticated approach to sort of looking at the problem. So you want to be looking at the scenario this fault happened in, and whether that was within or outside the operating conditions of the component or the engine. You want to look at telltale signs, like obviously I've mentioned, you use the various different techniques. Um, you you kind of want to have, yeah, you want to be. It's obviously it's easy to say you want to fix a fault quickly, but what you tend to have as well is you may, how can I put this as an analogy? You may have just put a band-aid on an amputated leg, if that makes sense, because you kind of just want to just find a fix really quickly. And that may have not fixed it. It may have maybe fixed it for a prolonged amount of time, but it actually haven't found the true root cause and actually tried to fix it. So it's definitely a tense. It can be a tense time, depending on the level of the fault as well, especially if it keeps reoccurring. Um, what you tend to have is different scenarios. Things you don't want to have is you want to start having like a blame culture where everyone starts saying, "Oh well, they're pointing fingers at this person didn't do this, and this person didn't do that." That can really kind of create a negative environment, which you don't want because that then affects kind of the morale and the ability to kind of come together and try and solve the problem together. You kind of want to really just have as best as you can anyway. Obviously, people are going to get tense, people are going to get stressed, especially, you have, races you're trying to compete in, and, it can feel like you're letting the rest of the team down, you're letting the drivers down, you've got a quick car, but, you know, like last lap, it's failed again, and it's the same thing. So it can be obviously be very, very stressful, but it's how you deal with that as a team that I think is really, really, really important. So yeah, it really just depends on the scenario, the team, the culture, and the leadership as well.
Absolutely, and I think a really great and insightful answer there as well, Judge, because you know, just us mere mortals that watch like the sport, we always kind of try and relate it to things kind of in our own lives, and into our own kind of workplaces. And like you mentioned too, like sometimes you're at work and there's an individual that does something, or there's a team that don't necessarily perform or don't identify something, and then that has a wider effect kind of on everybody. And like you mentioned,
Yeah,
kind of like in the high stakes, high professional, high pace work that you guys do, like ultimately there's not enough time. You guys have to kind
yeah,
of just work systematically as a team to kind of get to the bottom of these issues. And as well as that, it's just interesting to kind of hear how, like, in an ideal world, like you mentioned, it's just trying to like find certain solutions, but then sometimes you can only get a short fix whilst you're doing the research to find a long-term fix, and then
yes,
vice
exactly.
versa as well, how
Yeah,
that works as well. So
yeah,
yeah, that's a really insightful response, and I think one definitely our fans will be intrigued to learn about. So I'm gonna change it up as well, George. So moving away from the world of F1, let's get into like another motor racing series in the world of, let's say, GT sports car racing. So, for a lot of our listeners, they watch GT3 racing or multi-class racing, where you have like prototype cars, and then
mhm,
obviously like sports cars, which are quite similar but also different to their road car
yeah,
sisters. But in this one, George, the question is like, in the world of GT racing, you have a mix of both like naturally aspirated cars, maybe such as the AMG GT, and you have turbocharged cars, like, for example, the Ferrari or the BMW M4 as well. That's like a six-cylinder with like a
mhm,
turbocharged element to the power unit as well. In GT3 racing, the SRO is like the main body that implements having like a balanced performance to level out the advantages of all the different cars and power units. But the question is, what is the benefit of running a naturally aspirated engine compared to a turbocharged one? And I think a follow up to that, which is really interesting, at circuits like Kyalami or Mexico, how does altitude affect the power unit and the way it will perform with reduced power?
Oof, that's a really good question. Now you're putting me back to my British GT days. Well, say days. Yeah, it's minimal days, but still. Um, Oof. I think benefits of running a naturally aspirated engine over a turbocharged engine, yeah, on ground level, depending on how much power you can extract out of your naturally aspirated engine, I think you'd be in a pretty good space. You wouldn't have to deal with things like turbo lag. You wouldn't have to deal with ways of trying to solve that through calibration on the engine. So yeah, depending on the amount of money a team may have or cost and things like that, that may be a good thing. You may look at different ways to extracting power out of your engine. Yeah, I think when you're then running at altitude, I think it's something that again just affects all engines really, because obviously you have less air to suck in and mix with your fuel to obviously create mechanical power through combustion. Turbochargers, yeah, obviously come in to create boost and help with that. But yeah, I think really if you haven't got ways of trying to solve reducing turbo lag, which basically is you having a delay in how you can actually use the boost you're creating from your turbocharger. Obviously, it being based off of the operating conditions of your engine. So I think that's what I'll say the kind of the main difference is between running your naturally aspirated engine or your turbocharged engine.
Really great kind of analysis and kind of picking up the key points there as well, George, in between the two of them, because like as you mentioned too, they generate power in slightly different ways. They also give the cars a slightly different feel of drivability, which is a huge thing as well. And actually
Yeah.
another question that was linked to this too that a fan asked was how much of like the stuff we see in like Formula One or for example maybe in GT3 racing are we starting to see now in like modern day cars that like the likes of us can purchase? Because there's some manufacturers that have like now like a mild hybrid system, which is like basically in a very split nutshell, because I'm not the engineering guy here, but like almost like a starter generator unit that's electronic that basically helps with building kind of pressure in the engine in terms of the boost or recovering energy that will then go back to the starter motor. How much of that is derived actually from Formula One technology or even other series like GT3 racing? And, is that kind of a thing that's going to continue in the future as, we continue to, develop and see kind of greater designs evolve over time?
Yeah, I mean, obviously, historically, that's always been the case. I think there have been a lot of things that are developed within Formula One that found, or other motorsport series that found their ways into road cars. I think I'll speak within Formula One. I think more recently it's been a bit of a plateau to an extent, just because of the crackdown on regulations in terms of making, I guess, the sport a little bit more competitive, a bit more fair. So there's not really been many, I guess, big game changers so far. There have been some that I think I will speak on them. I'm not speaking specifically, but it's more within inside of the engine. So the more recent developments within internal combustion engines have to do more with, put it plainly, how we're mixing fuel and air and how we're basically burning it. So you have things like omega bowl pistons, which is basically a specific geometry of the piston, and that is used to try to mix the air and fuel a lot more effectively. You have what is known as oh god, it's just escaped my mind, but essentially it's I'm going to describe it anyway. It's basically a mini cylinder within the cylinder. So what you're trying to achieve with that is you're trying to achieve what is known as stratified combustion, where you have a rich mixture within the middle next to the spark plug and a more leaner gradient going outwards. So with that, you're able to create quicker combustions. With quicker combustions, you have a more efficient combustion. And with more efficient combustion, you're able to essentially get more power out of the energy you get from your fuel. So, for instance, that's something that's definitely been played around with in Formula One. And you find that in a lot of your high performance cars, like the Koenigsegg uses that. You have other car manufacturers as well that definitely have that working within their engines. You have ones that are passive systems. You have active. I can't believe the name is. I can't believe the name of this has escaped my mind. This is ridiculous. But
you remember it.
You have active. Yeah, you have active systems where you have an additional injector within this mini cylinder, and passive ones where you basically have an injector outside it, but the spark plug is still embedded within it, essentially. So you have things like that. You have injectors as well. So the injector geometry, in fact, one that I worked on in university that was in development then, but it's definitely being used now widespread within the industry, are step injectors. So step injectors, you're able to create a fluid flow geometry that's essentially able to sort of encourage mixing within the fuel and the air when you're obviously injecting fuel into the cylinder. So you have technologies like that really that will subtly find their ways into engines in road cars, and there are also obviously technologies that aren't in Formula One because they've been, I guess you say, outlawed through regulations, but you kind of find them in more high performance hypercars and supercars and things like that. I wouldn't necessarily say road cars per se. You may have sort of, obviously Koenigsegg have their free valve system, which is essentially just an electronic valve train. So you do away with your camshafts, you do away with trying to use your crankshaft to obviously provide through the gear train cam timing to your valves. You kind of do that electronically. You have things like that. So I'm still thinking of the system that I was discussing with the mixing of fuel. But yeah, so you have different technologies like that really, and again, I think outside Formula One as well, those technologies are being used within engines.
It's really fascinating to learn about, George, and like you mentioned there too, like there's so many different ways you can go about it, and in some of the higher performance stuff we're seeing as well. You mentioned Koenigsegg, and they've always been renowned, for pushing the boundaries and kind of taking the kind of engine kind of development that direction, and even again with Mercedes as well, and they're kind of like Project One, which is like a derived 2016 regs engine, which then had to been like homologated to live by modern day European kind of emissions and stuff like that as well. Is really crazy, and I guess a testament to engineers like yourself that make it so eventually the technology we see on the racetrack makes its way into cars. Although I might have to either ask Georgie for a little raise or perhaps win the lottery one day to get one of those cars. But we're working on it. But absolutely. Well,
sorry,
on the topic of
pre-chamber ignition. I apologize. It's pre-chamber ignition. So that's what the technology is called.
Oh, okay. I heard the expression or term before as well.
Yeah, so pre-chamber ignition. So you're essentially igniting a rich mixture of fuel within a smaller chamber within the cylinder. And what happens is essentially out in the main cylinder, you have a more leaner mixture of fuel. So you're creating that gradient where you have a rich mixture. When you ignite that, you're basically spreading it kind of within the cylinder from to have more homogeneous mixture. And by doing that, you're kind of creating not really sort of like a chain reaction, but not really. But what you're doing is you're making sure that you're burning the fuel a lot more effectively by basically spreading it outwards. And that way you're basically able to use the amount of fuel that you put in a lot more effectively.
Absolutely. And yeah, just like you mentioned too, it's so wild to see just how like things have moved forward. And although I guess in terms of F1, because of the regulations and trying to kind of at some sort of like level of like, I guess, stability with it, there's still kind of things which we see engine manufacturers doing either outside the track or kind of influencing in terms like you mentioned as well. And it's exciting. It's a very exciting time to say the least. To see how it goes. And on the top of excitement, George, I've got more exciting news for you, man. Because we had a bit of an upgrade. We had our South African Grand Prix, which we've been asking now for 5 years at least. Come through. So on another new topic, we've had Stefano Domenicali come back with an update to us all. Basically mentioning that he's working very hard with the promoters and obviously the South African government to try and push for a Kyalami Grand Prix next season, which would be grand. It'd be really exciting, bro. Just wanted to get your thoughts on this as well. How excited would you be to see obviously Formula One return to South Africa, considering it already has its heritage in motor racing history and obviously with F1 in the past as well. How much it would
Yeah,
mean, to see F1 in that region of the world when we haven't seen it for so long, and Formula One's almost become, Europeanized in that sense. And also, like,
yeah,
what kind of
yeah,
technical challenges, would an engine manufacturer have to consider for a track like Kyalami, which again, very high altitude, loads of kind of compressions, and kind of like lots of short corners as well, where you need kind of like more torque or instant delivery of the power to kind of give you that drivability.
yeah, yeah. I think first of all, I think it's absolutely fantastic. To be very honest, I think South Africa was a much different country last time they're racing Kyalami, so it'd be very good to kind of see Formula One kind of racing in that environment. I think it will be very new. I think maybe the most similar um, environment is probably into Lagos, I'd say, but even that's still not like that. So I think racing in Africa again, I think would be absolutely amazing. So yeah, that would be great for the sport. I think it would kind of bring it closer to a lot of fans that obviously have gotten into the sport for a while. So I know Formula One has grown in popularity, or maybe it always was popular around that region, and that's Southern Africa, so Zimbabwe, South Africa. Um, so I think yeah, it'd be absolutely fantastic to take it over there. I know that it would definitely be a hit. Yeah, I know South Africans will come out and show out and kind of give a great show. Uh, in terms of what engine manufacturers would have to kind of look out for on the track, I think really and truly it would, in terms of the corners, that wouldn't really be, I would say, a massive issue. I think it would just be a case of kind of applying certain engine maps that are more torque heavy around those quick corners in order to kind of come out of corners a lot better. If you have your top end power, again, that would always be good for you anyway. And in terms of the high altitude, I think yeah, it's like I mentioned before, that would be something that, see, according to the current regs anyway, you've got the MGH, which is able to help with the turbo lag in that sense, in being able to kind of kick in the boost that you need. Again, coming out of corners, which can only help you with your torque. So these are the kind of things that I think engine manufacturers will have to basically kind of consider.
Yeah, I think that's a fair response there, George. And again, it's interesting, and I think just like you, we share that like level of excitement because it's something that's been on the horizon for so long. There's been so many different obstacles that have been kind of intrusive in enabling it to happen sooner than later. But to see it still as a discussion, to see it still as something which the fans are still wanting, is a sign of progress and hopefully things to come. And also kind of this on the engineering side as well, like you mentioned, like having different engine maps and how that would influence the way the car will drive and the drivability.
Yeah.
Like you mentioned as well, just how
Another thing, sorry, I was just going
Mhm.
to add another thing to consider as well would be, again, it really depends on the time of year. I'm not too familiar with, well, I'm pretty sure South Africa's gets pretty hot throughout the year. How hot it gets, that's another issue, but that may be another factor to kind of play around with as well. Managing engine temperatures, during running, um, because you can get a lot of engine failures tend to start off due to overheating. So rejecting the heat that you're making from the engine, I think, is very important. And in areas of high altitude, high temperatures, that can be something that can be a lot harder.
Absolutely, and kind of on the topic of that as well, Judd, because you've spring me to ask another question on that. How, I mean, just generally speaking, how does one go about replicating that, back at the factory? Is it a case of putting the engine on like a dyno and like trying to replicate the the temperatures or kind of the conditions that engine's likely to be subjected to in reality? Is it a case as well where we hear these crazy stories? I think it was like when Honda came back into the sport with McLaren, that back in Japan, they'd have these Honda engines like on dynos for 24 hours a day. And I was like, geez, I would not like to be a Honda engine. That sounds like stress. Like, this is it something akin to that, or is there a way that, manufacturers can go about at least trying to simulate what they might see before hitting the circuit in that regard?
Yeah, I think all those things, you do it through simulation. You'd have elevated engine temperatures, elevated coolant temperatures, inlet coolant temperatures. You try and replicate that on dyno as well. You can replicate that within subsystem components on rigs, for instance. You could even replicate that through hot testing through the car as well. So I think those would be all the different ways you would try to make sure, well, the engine kind of still performs within its desired functionality or operating conditions at elevated temperatures, for instance, or elevated altitudes, for instance.
That's interesting. And again, kids, George said hot testing, not hot boxing. So don't get the wrong idea, and don't blame us for anything that happens outside of this podcast. But no, thank you for that, George. That was really insightful. And we're gonna line it up with the final two questions because we've had like some fantasy questions in from our fans, and one got me really thinking, I wonder what he would go for. So I'll put it forward to you, George. Like, they've asked George, what is the best sounding sports/race car engine? They've basically put 3 static answers here, and then they've put a wild card, which I'll explain in a minute. So the options are, George, Michael Schumacher's Ferrari 2004 from 2004, V10.
Okay.
V10, like I remember the days my dad used to, we didn't have alarms in the house on Sunday. It was just Michael Schumacher driving around. To be fair, you got that. Candidate B, the Mazda 787B rotary engine, which again, just very unique sounding car, very high pitched. Kind of history behind that car as well. I think it ran in Le Mans, and then it was so dominant that whoever was the governing body at the time just said, nah, no more rotaries, because they're just so unique in the way that they are and the advantages that Mazda were able to gain. So there's that. Then, going a bit American here. Option C was a Dodge Hellcat Demon, where we are praises of God for the most part, but they put the Demon version of the Hellcat, which is a V8 engine, naturally aspirated. So again, very unique, distinctive sound, very torquey engine, probably enough power to bring my girlfriend's house down, which would be useful one day. You never know. And then D, the wild card, is a choice of your own. Choice of your own there, George. So what out of the 3 options that we've added, and then the final kind of one, which is your choice, what would you say is the best sounding like racing or sports car engine that just sounds like music, sounds like Beyonce to your ears anytime you hear it get fired up on the circuit?
It's funny because it was actually going to be a V10 Formula One V10 engine. I would have gone. So I think I'll go with the F2004, but I think my wild card would be the Williams BMW engine, the V10.
Do you remember that lap by Pablo? I think it was Pablo Montoya.
Juan Pablo Montoya.
And then using that beer, and then this on the revs in 6th gear, or can't remember how many gears they had back in 2004-ish, but must have been like 6 or 7.
Was it? Okay, 7. Okay, all right. Can't remember, to be honest.
It's the same here, man. I was only small, bro. You were older than me in school. I should have been bullied. I should have been sticking it on you. I'm sure about that, bro. But, oh man, yeah, this the BMW powered V10s from that era as well, just nuts. And then, funnily enough, even in the road cars, I think they're putting V10s in. Obviously, not anything like the Formula One, but I think the M5s at that point as well had V10s in them. So yeah, just an amazing time to be alive. And all right, let's kind of like post this question a bit more as well, George. V10 or V8? Because see me, I'd say I'm a bit more of a V8 guy. Oh, come on, guy. Bro. So all right, you're gonna pull up in the Lamborghini Huracan. I'm just gonna be in the C63.
Yeah.
Okay.
Look,
okay,
man,
bro.
I'm a V10 guy, to be very honest.
You're not the only one. Seb would agree with you.
Yeah.
No, that's mega. That's mega. Well, final fantasy question we got for you, George, then is this. Listen, George, Stefano Dominicali just rolls up, man rolls up with his squad, pulls up to the crib, and he says, George, I've got a proposition for you, bro. I want you
All right.
to come over to the FIA headquarters. I need you to cook up a madness for me. I need you to build your dream engine spec formula. And basically, he wants you to describe to all the FIA engineers there, kind of like what type of engine you'd want to bring it into F1 if you had to say, and what advantages would that have over the current turbo hybrid V6s we currently have.
Wow. Okay.
Yep.
Okay. So, all right. First things first. VVT. Yes, yes, please. Variable valve timing. I'd like that to come back in, please. There's so much scope of development that can be done with that. So that'll be the first thing. I think loosen up some of the restrictions on certain exotic materials. I think that what I'll do to make it interesting is I'll loosen up the actual use of the materials, but I'll still keep in the cost cap, so that in a way kind of limits the amount, but you can still use it, but in certain amounts in certain places. So that would allow you to then be creative with looking at the most important places to use these materials. So talking magnesium, other kinds of exotic materials as well. What else? In terms of the architecture, obviously based on my previous answer, I may. This is what I may do. I'm going the opposite way from what we're doing right now. The ERS system, I think I kind of like what we've got right now compared to what we're going to get in 26. I do like the MGUH as technology. I think it's a really good, innovative way of recirculation of energy within the power unit. So I'll keep that back in. However, I would bump up to a V10 just because we're going to keep the use of sustainable fuels in the mix. So if we're worried about emissions and things like that, it's hopefully covered through the fuel spec, because we want to get kind of more aggressive kind of sound out of the engine. But with still using electrification, because it's very important for the environment, but also I think from a technological and development point and a performance point of view, I think it's a very interesting way of kind of utilizing what you would kind of consider waste energy from the engine, hand in hand, not just the engine but the vehicle as well. And you're kind of using that through the ERS system or the ERS to kind of add more power that you can kind of utilize within the power unit. So I'll kind of keep that in there. What else would I like to see? Wait, open up.
Overtake.
Party mode is not going anywhere. Just I shouldn't have said that, but
I've got you.
Because at the end of the day, plainly put, right now, I already mentioned obviously kind of one of the main factors in engine development today in Formula One, because everything down to materials, the geometry of the engine, ways you can extract performance quite easily is heavily constrained. So really and truly, all you need to do is make sure is that you're able to achieve really, 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 really high, well, it says that, high combustion pressures, and you hope that you're able to design the structures within the engine to kind of contain those combustion pressures. Then you get your power. That's plainly put how it is at the moment. So I don't think party mode is ever going to go away, because you're always going to find ways to kind of extract more power and have that embedded within the engine, and then hope that it's able to sustain it. Because that's where your reliability comes in, really. Lack of reliability is when you have an engine that's able to produce a lot of power through high combustion pressures and high combustion temperatures, but the structural elements of the engine is not able to take it. So over time, they would fail. So that's pretty much it. So all I'm saying is that I'm trying to kind of allow a bit more creativity kind of outside the combustion chamber.
We like creativity, and Stefano as well. Listen, you heard what we want. You heard from the man himself. Give George what he wants. Listen, give him what he wants, because that would be a mad formula, and I think one which will get everybody excited, because like you mentioned as well, there's an emphasis obviously on not going too crazy with the resources and being kind of like, I guess, responsible for the environment to a certain degree. But also, like you mentioned too, that element of creativity, if you allow the teams to kind of source the more scarce or more exotic materials, how would they go about using those? Are they going to use it in a sense for specific races which are very power unit dependent? Would they find ways to kind of sustain performance, maybe not at such a peak, but in a sustained, controlled way through those high combustion measures you mentioned as well throughout the course of the season? It would be interesting. And then I think the fan favorite thing you mentioned there as well, George, is just the V10s, man. Just how musical they sound as well, and just having, it could be done, because I think, like if you really put resources and time towards it, it's something which might be possible. And then on top of that as well, it's something which people have always talked about. And we've seen even with like maybe not such a complicated engine, but even just Sebastian Vettel doing his little demo run in the Williams 14 WB, and just how you're able to take a car that's like a modern day classic and make it more sustainable for the environment using like, eco-friendly fuels and stuff like that as well. So something that definitely I hope and wish, in the next kind of like 10, 15 years, we see, we already have Formula E and so forth as well, in terms of the really hardcore kind of like electronic kind of aspect of things. So to have like an ideal world where you have a combustion engine mated obviously with the ERS system, as you mentioned, with the MGH as well, would be really interesting to see, and to kind of to free it up a bit, but then not to make it so broad that then you kind of have like a cost spending war as we've seen as well. But it'd be wild. It'd be wild, George. I agree with you.
Yeah, because I think with that you just have, because in a way, obviously that's kind of what's happened on the aero side. It's been made to be a lot more simpler. So obviously last year you had different interpretations of how that could be approached, and obviously you saw people going one way, oh, that guy's doing well, let's follow them, and there was the other way. So I think having a similar thing with the engine, that just kind of promotes more innovation, and that's how you get more ideas and more ways of looking at things that I think is currently being done outside of Formula One. So I think that'd be quite nice.
Absolutely, and that's the thing as well. It's like, it's great obviously as a spectator to see the involvement and kind of just to see how far the technology's gone, but as you mentioned as well, to see it kind of like being an inspiration or a focal point for other manufacturers to take and implement into hypercars or sports cars, and even just to see this in very loose kind of aspects as well, how they'll take a very complicated component and then simplify it for something that could go into everyday road car as well, is immense. And again, a really high kind of commending point for guys like yourselves, that are there, that kind of do the hard hours and the brain busting, to make it possible, and to kind of see these progressions in performance as well, because ultimately that's what it comes down to. So really exciting, George. And again, another banging episode, if I do say so myself. So before we wrap it up, George, man, we kind of started off with you and kind of just a catch up. Bro, what did you get up to over the Easter holidays, man? Were there any remote control cars? Was there any kind of like, Lego building, anything at all you want to let our listeners know about at all? And again, we covered it like previously, but like, any kind of advice out there, and where can they find you as well?
So over Easter, I actually also kind of last week as well. So I've kind of been working on, well, how can I put this? So there's kind of been a bit of a kind of like a getting together, so like an assembly kind of forming. So last year, so there's an organization that I was still a part of, but I was part of the executive board, known as the Association for Black and Minority Ethnic Engineers. So they basically kind of looking to trying to increase in the proportion of Black and minority ethnic engineers in various different industries. So not just motorsport, but automotive, oil and gas, rail, whatnot. So when I was part of the executive board, myself and some other engineers of African Caribbean origin, we put together an event that was called Full Send, and we kind of just discussed where we are in terms of diversity and representation in motorsport, and kind of where we would like to kind of go. It was a bit of a celebration, but also kind of ways that we want to look at kind of moving forward. So obviously you've had initiatives like the Hamilton Commission, which kind of looked at tackling kind of where we were, problems within working in industry, someone of Black or minority ethnic background, and ways that we could go about improving that. So what has happened since then is a lot of us that are in the industry or around the industry, we've basically kind of sort of teamed up, and we've kind of formed I guess you can call it a club, under Motorsport UK, which are basically an organisation tasked at kind of really running motorsport at different levels within the UK. So I think I believe it's the first of its kind, I should say. So we're kind of like the first club that kind of focuses more on background and in improving and kind of sharing the knowledge of getting into the industry. And the club's known as Driven by Us. That's Driven by Us. So we just started up. We're looking into loads of different interesting things. Obviously, things that I kind of described, I was kind of trying to get into in terms of advice for younger listeners or people looking to get into motorsport. This is going to be basically a platform where we can kind of offer that advice and trying to help as well. So kind of covering different educational schemes, or even trying to put together. We have the power to put together championships, karting championships, or like whatever, that sort of thing. But just kind of bringing about a hub of innovation, of kind of activity around motorsport, and it'll be an environment where kind of we're really kind of participants of all ages, young, old, that are interested in motorsport. They can have a space where they could learn, they could kind of express themselves, they could, as in, technically, and kind of be around like-minded people, and that could kind of help them if they want to get a career in motorsport. They can have a ground base or experience within that. You can create links with different people in the industry. Kind of have that knowledge sharing, which I think is very important. Kind of want to move together as one. So yeah, basically we're a club. I think you need 25 members in order to form a club. I think we've got around that number, more than that, I'm not sure. But yeah, from all over the world, we have people that are in F1, people that were part of F1. We have people from all over the globe, to be honest. We have people that are in GT. So yeah, it's I think a great initiative. So Driven by Us, you can find us on Instagram. I believe it's at Driven by Us. You can find us on LinkedIn. I believe we have a website that we're looking at launching. So yeah, that's kind of what I'd like to plug. I'm on social media, but not too active. So I'm going to be very honest. I kind of try to stay away from Instagram, Twitter, just because kind of, I guess as an engineer as well, you kind of look at yourself like an athlete, or like a not to sound too serious, but kind of like a monk. You kind of want to make sure that you have a certain mental diet. You don't want to be consuming too many things that don't help with kind of like how you want to be as an engineer. So kind of that's what kind of comes into it as well. Kind of your concentration, kind of like your fitness level if you're an athlete. So you kind of want to make sure that that's something that you want to keep at an optimum level.
Yeah, that's amazing, Judge. And again, as well, like to kind of touch on the things you mentioned there as well, Driven by Us is an amazing initiative and definitely one I'll be signing up for as well, now that I know about it, because, it's so
Awesome,
key,
awesome.
to have the representation, to have, people like ourselves, which don't always get the opportunities in positions now to kind of do the things that we're doing and to teach each other and to kind of be a place of knowledge, because knowledge is
Yeah,
wisdom and wisdom is power. So more empowerment, to the amazing work that you guys are doing, and super proud of the stuff you're doing as well, bro. In terms of even the social media point you mentioned as well, it's the same thing with me too. Just like, obviously I have kind of spells where I'll be on it, but I agree with you. You have to be very careful of what you consume out there as well.
yeah, yeah,
If you're somebody looking to kind of be at the top of your level or top of your peak and stuff like that too, there's so much kind of stuff that you need to kind of like, focus into to really be able to get and extract the maximum performance from yourself. So
mm,
definitely respect that too. And absolutely, it's a really exciting time. We're
mm.
really happy, just to kind of hear about the stuff that you're working on as well. And obviously, Red Bull be winning. So, we know that you're doing a good job on that side as well, bro.
Well, yeah, yeah. I mean, to be honest, obviously, I'm working on the 26 engine, so to be very, very honest, and to kind of put it plainly, I haven't really got much to do with the current success Red Bull are kind of sort of doing. So we just hope we're doing our very best to work hard to kind of keep that momentum going.
It will come. It will definitely come.
Yeah,
Jordan. And again,
yeah,
I'm so excited about it as well. Because although obviously at the moment there's still a lot of stuff we can't talk about. It's practically almost like an NDA thing almost, but it's
yeah,
it's
yeah,
it's still interesting just to kind of see what goes on behind the scenes, and to even just be like, I would say, a fly on the wall, just kind of like there, just kind of seeing kind of some of the considerations that go into it and how some of the teams go about it, and just the kind of world that is motorsport engineering. So,
yeah.
George, we're super proud to have you, man. And on top of that as well, definitely a lot of catching up between us to do. Bro, when you building that sim rig, bro?
Ah, I knew, because I know
Bro,
last time
bro,
I said
bro,
it, but
bro.
I'm
Where's it at
sorry.
though?
Listen, man, it's still a concept, it's at concept level. Unfortunately, yeah, just finding the time to actually focus on that. Unfortunately, hasn't really been there. Obviously, yeah, there's obviously personal things as well in my life that, in terms of move to the next chapter, that's going to take time as well away from that. But I'll do my very best to kind of keep that space there for that to obviously be brought to fruition, for sure.
The
So
best
yeah,
way, George.
so it's still coming. I can't say when, but yeah.
As long as it's coming,
still on
bro.
the
You're
agenda.
not running
Yeah,
nowhere, bro.
yeah, still on the agenda.
We love that. We love that, George. Well, listen, it's been amazing to have you back, bro. We definitely need to
Thanks for
have
having me
another
on.
part two installment of this later on in the year as well, as things kind of
Mm,
open up and as we kind of see kind of the direction of just where things are going in the kind of engineering side of the world, of course. But yeah,
yeah,
just man, it's always a pleasure to have you, man, and it feels even closer to home for me because of just knowing that we went to exactly the same secondary school as
yeah,
well,
yeah,
and see
yeah,
the
yeah.
heights you're at as well, bro. So if take it from me, people, like if you really put your mind to it, if you really want to achieve it, if you really put the hard work and graft into it, and kind of just stay out of trouble, just do what you need to do, you can be like George, you can be successful, and you can be part of something major, which is something I definitely want to be able to, to definitely rant to my kids about in the future.
Yeah,
So
yeah, yeah.
looking forward to that. Looking forward to that, George. But yeah, any final words before you
Awesome.
wrap it up, man?
Um, yeah, man. I'll just say, yeah, just look out for Driven by Us, man. Look out for Driven by Us. I think we're going to be doing a lot of cool stuff. There are a lot of guys kind of involved, that you'd see, that'll be coming out of that, and yeah, I just hope it's a great initiative that's able to help a lot of people.
Oh, that's wonderful to hear, George. And definitely, I'll be using my platforms to, to put that to the forefront as well, and to
Awesome,
promote that
awesome,
and to
awesome,
put eyes on it. And of course, as well, the amazing boss lady Georgina will definitely be doing God's work to make sure that
awesome.
reaches, everyone that, has to be a part of that journey as well. So super
Yeah,
excited.
yeah.
George, super thanks for your time, man. We really appreciate it. Bryson, man. Bryson was super excited as well. We had you on in season 1, so I know he's definitely excited when he sees this too. But yeah, man, just keep up the amazing work, bro. We always got your back. And yeah, definitely looking forward to hearing more about the progress and these things forward. So yeah, that's been us at Stripping the Dipping. It's been your boy, AMG Dent, aka Modern Day Morgan Freeman. And until next time, enjoy this episode, and we'll be back hopefully soon with some more bangers. Call me DJ Dens because I select absolute bad tunes. And until next time, we're out. Peace.